So I haven't even cleaned the bed. I'm getting naffed off cleaning this bed for no reason because it just doesn't stick. So I've left it as it is after the last print was on it. I've turned the print round to 45 degrees, as you can see. I have took the roll off of the unit, the filament roll, I don't know if you can see it in there. It's now on top. I don't think you can see it in there. It's on top of the thing, a bit like a sidewinder. So on top of the box here, there is no filament, it's all inside. I'll be able to see it better now, I don't know. You can see it in there now? I think you can see it. No, maybe a little bit, I don't know. No, it's on top of the frame there now. The whole thing's bolted on. So we're going to get some vibrations. To counteract the vibrations, I have made these. I haven't made the brackets to fit them yet. As you can see, they're not fitted, but they will go at the back, so I don't knock them and they don't get in my way when I'm doing stuff. So that's the most promising it's looked so far. I think we're at Z height is 1.5 millimeters. It's doing 0.4 millimeter layer heights. I think the first layer height's a little bit less than that, so this is probably the fourth layer, and it hasn't even attempted to start peeling yet. So you can probably see it already through the hatch. Let's grab over that. And there she is. The next failed attempt. Let's put it down there so we can get some light on it. So there's the texture. And as we can see, it's a very consistent first layer. Well, as far as I can tell. I haven't really looked at it yet, I've just come in here and picked it up. Lots of stringing. Not to worry, I wasn't really bothered about the stringing. But it started peeling up. You can see the edge. So it started peeling up around about third layer, fourth layer. I thought I'll leave it, but it's just become a banana. Okay, so I've put some black PET G back into the dryer, ready for tomorrow's attempt. Right, I was getting very annoyed. So I took the Creality bed off, and I put the glass bed on, and I coated it with glue stick. Yes, with decorating as well. Original Pritt stick. And I watered that down and smeared it around. So it started again. Oh, it's frustrating. Now you can see the odd shaped angle of the glass, and it just fits on. And you might be able to make out the streaky lines of the watered down Pritt stick, PLA glue, whatever it is, PVA glue. So I think you can see the stringing in there. It's quite hard to focus through the plastic window. And is it peeling? Yes, it's peeling. So it won't stick to PLA neither. So I'm pretty arsed off basically. And I'll let it run for a while and see how bad the curl gets. I don't think there's enough filament left on this roll to do this print anyway. So I've been consumed with 3D printing now for the last couple of weeks, and last night this is what I was getting. Very nice glossy surface, sticking not bad, but then it's starting to peel at the end. Just you see the end there, it's just curled up, just starting to peel after a couple of layers. So I dried this black PET G, and I decided to up the temperatures a little bit to 245 from 240, and the bed up from 90 degrees to 98 degrees, and it just wasn't sticking here, and under extruding I think. Good grief. There she is. I am up to, where are we at now? 98mm. Alright, you'll see it when I'm seeing it. I've just come home from work. I know it isn't perfect because I checked it this morning. And that's what we get. Just turn the light on in here. If I can. I think it's on. It is now. There. So it printed well up to about this stage here. And I came down and checked it before I went to bed last night, and it was up to about here. And it was still in one piece. Now I woke up this morning and it was up to about here. It had cracked here and cracked here. I didn't know the full extent of it. It's still stuck to the bed. Oh yeah, it's still stuck to the bed. Well, the tree is anyway. The tree is still stuck to the bed. Yeah. I don't know if it's going to come off. Oh yeah, okay. Okay. Well, the tree's falling off of it anyway. So this is the tree structure inside. I'm not sure if it's come off of this alright. It might come out. There we go. Look at that. It's like a manifold. Look at it. That is awesome. So there we are. It's a draw liner. Clearly it needs spacing out, but the idea of this draw liner is, oh yeah, it's like a hinge. So I know these drawers are only very thin, but I'm sure you can appreciate that if you just put a layer of pens in there, it's a bit of a waste of a drawer. But if you could somehow have a hinge system and have a flap which lifts up and comes back down again, you could have a row of pens on the bottom and a row of pens on the top, and if you want to get to the pens at the bottom, you just flip up the flappy thing. So in conclusion, I think, I don't know whether it's conclusion or not, it's been a long time since I've done a video. Anyway, I've made this. Can we see it? Sort of. The lighting in here is really bad. Well, we could put some more lighting on, couldn't we? And you could see it. There we go. Now you can see it. So it's starting to look like the object now, isn't it? That is the cold end of the hot end. It's a bit of a tight fit. That looks similar to the normal cold end of the hot end. That's my fan holder. It's a light press fit, and it's going to have that silent fan on the front of it. Now don't get me wrong, 3D printing is okay for stuff like, you know, making a mask for a costume, or, you know, making the odd low impact thing. That's 4 layers thick. It's not bad, you know. Oh no, and then it breaks. You find places where it's brittle. Okay, so that's 2 failed prints. That print did fully print out, but it had warped. You see the... Hello again, here we are at the CTC 10S. It's in bits. That you can just see down here. Here is the control box. It isn't inside the enclosure. Makes for a better all-round situation. So I have made these, and they will go in here, around about there to around about there. What that does, it gets these bars outside the diameter, outside the area of the frame, and it puts the bars behind, so my hand, my arms, I've got nothing to collide with. Now you might have a different version of the CTC 10S to me, but I know on mine I get a lot of curled prints. They just peel themselves off the bed. You see the bend in that? And it's like a banana. Let's do another print, which may involve a bit of shouting. It went for a trip across the floor because I was getting sick and tired of it. It's a banana, let's face it, it is a banana. The things aren't sticking. Now I ran this, according to the display over there, it said the bed was at 98 degrees centigrade. So we have to wonder what's happening onto the temperature and the curling. So I was thinking to myself, maybe the heater in the bed is not quite what it makes out to be. Now mine has got all this insulation underneath it to keep the heat in. Very nice. But I've just spent the last 25 minutes peeling that off with a knife. Made a bit of a mess. That is what you get. Two main problems I can see with that. And I'm no 3D printer engineer, but I can see two major problems with this. One major problem is the thermistor is on top of the heater pad, or should I say directly underneath the heater pad. And that says to me that as soon as this heater pad gets to the desired temperature, things will cut out because it will tell the computer what temperature it is. Whereas we want to be measuring what the bed is above it. That's no good. Now I've measured this. I'm going to take measure out. We'll show you. And the measurement says that is a, sorry about the rocking, just nudged you. That is a 10 centimetre by 10 centimetre heat pad. Now, I've been pricing up silicone pads for this bed at 300 millimeters, and they are 750 watts. I don't know if you can see the discoloration around here. Can you see that discoloration? I think you can. I suspect that is where the major heat is. And so when one of my prints that was on there, that was on that orientation, you can see why it peeled off, because the outside is too cold. Oh, there's the problem. I found the problem. And it's a problem. Captain, we have a problem. They fitted a 100mm by 100mm bed heater to a 310mm by 310mm bed. It's not going to work, is it? Now inside the 3D printer enclosure, at present I've just got one of these lights here, and it is running down here off of a little battery. I'll take one in a second. There we go, turn it on, and then we switch it on, and we get light come out of it. It's not convenient, but it does the trick. So we had a car in the other day, and someone had fitted a device like this. In fact, it was this device in their dashboard, and it has a push on push off switch. Attached to the end of those wires was these. So you got that light there strip and that light there strip. They are pointing towards the 3D printer. I need to get them working. These as though they were in a car, and I have no instructions. They're 12 volts as far as I'm concerned. My power supply in this 3D printer, 24 volts. This is an inexpensive, I think £2, £3 off of eBay, 12 volt variable voltage regulator. It can take an input of up to 40 volts, I think it was, or up to 24 volts or something like that, and it can regulate from 3.3 volts up to 20 volts. It's a buck DC to DC converter, so I've got to fit that. I have these connectors so I can do a quick release on the outside, and I have the wire here coming from those two going through the side into the printer there, and I've extended all my wires for the box so it's twice as long now so I can get it further away. Right, I think I've got a good setup here now so I can show what's going on. I have put the 240 volt power lead back in. Before I screwed it into position, I suddenly realised what I need to do is set the trim pot on this to the right voltage. I've got the meter set up to reading 200 volts DC. This might smoke straight away, but we will find out now. No, and it is set to 12 volts and the lights are on. Great! So I have lights. I don't need to do any adjusting. I don't think anything's going to go pop. Sorry for nudging you there, I just nudged you. Excellent. No smoke came out. Well, not very videoistic. I didn't want to blow it up, but if it did blow up it would have been quite amusing. Just taking a quick look inside the box before I button it up. You can see the standoffs are in there now. The thing is in there nice and sturdy. And I was talking about a trim pot. So this is a potentiometer, and it's for trimming the voltage, so it's referred to as a trim pot. They're not always blue, but they've always got a little screw in them. There's a little brass screw there, I don't know if you can see that. So that is the screw, right there. And you would literally put a screwdriver in there and turn it. It's actually best not to put a metal one in there. It's actually best to get a plastic screwdriver for them, but you know, these are not expensive electronics. It didn't need adjusting. You can see the two standoffs in there now. It's all nice and tight, and there will be air blowing that way, so that should keep it nice and cool. It does eventually get to 100 degrees on its thermistor. 55.4, 55.5, 55.7, 55.9, 56. I've seen a 56 now. 56 in the centre, and 36 at the edge. So it's still got a 20 degree variant. And there's no way a print's going to hang on with that kind of temperature differential between hottest and coldest. So trust me, just upgrade to bed. 52.9, and now it's the outside edge. 32.9. It's a 20 degrees centigrade difference, and the uncovered bit is at 40 degrees underneath it. Interesting. That's pretty hot. Yeah, and that's cooler. I can't feel that difference in my hand. Maybe the reflective surface is reflecting some of the heat away. That's why we're getting such low figures now, because it's up at the temperature already. And now the computer for the 3D printer is saying 100 degrees centigrade, so that's fully heated. It will be going into the PID cycle now. and you'd be expecting to put your print on that. Now at 46 degrees centigrade and 50 degrees centigrade and 39 degrees centigrade and 47 and 37 and 38 and 37, and you'd be thinking, yeah, I can put PL8, I can put a PET G print on that. Blinking Nora, 100 degrees centigrade, I could put a nylon print on that. No, it's going to peel off. Forget about it. Battery's nearly dead on this thing now, so I'll have to put it on charge overnight to take it back to the person. So there we go. You've now seen it with a thermal imaging camera as well. For the time being, these are the settings I'm using for that print, which has started. The bed can get to 107 degrees centigrade. It struggles to get past that. And here's the print at the moment going. It's nice having lights in there, you can see it straight away. And at present it is 1/3 through. It's only a 2-hour print, this one. And it is a bracket to hold the lamp for inside here, so I can put another lamp inside. Hooray! It is printed. We'll just switch the lights back on again. There you go. She's printed! So it can print PET G. There might be a bit of a layer shift here. I think there's a bit of a layer shift here. There's still a lot of heat in it. 52 degrees it's saying. Switch the lights back off again. So there's the failed print next to it. That's where it failed. Oh, there you go, now you can see. It wasn't far from the top when it failed. Very disappointing, that was. But I have one. Can it come off? No. Yes, it comes off. See how it is stuck really well, but it's when you get a cold bit and it pulls and it just can't hold it, so it is stuck really well. Ta-da! Like magic, it just appears in front of you. So it's a little bit scuffed. It's got a few chatter marks in it, and scraped a little bit, and a few washes. It's obviously an end, and then it's got even more scratches in it and dings in it, but it should be 310 millimeters square. 309 by the tape measure by 310. Close enough, eh? So that's 310 by 309. Plan of action. Obviously I've ordered the Canuvu heat bed for it. I need to put the holes in which correspond to the standard CR10 holes, which will correspond to the Canuvu. And I might even get I'll just put a 3mm bit underneath it. That means it'll be an 8mm piece of aluminium. It's not particularly heavy yet, but there she be. That will be fitted in there before long. So we're looking inside the CTC printer, and this is the first light that I put in. That just enabled me to be able to see what was on the bed, as you can see. Now let me switch the base unit on and we'll see what the new lights look like altogether. That's altogether a lot clearer. And now I'll put the original light on that I put in. And that just accents it a little bit. Just in case I need a little bit more light. So the lighting system, very good now. Here, on the Z axis, is a filament sensor, filament runout sensor. Now I've modified mine. See a little brass piece in it? Well, that little brass piece makes the sensor work. Took me ages to make that little brass piece, and I want the filament sensor to work because I've modified it and it works. But when it does a retract, it does that and comes off, and then it ends up being in that orientation there and restricts the flow of filament into the extruder and then causes under extrusions. That is now blued, And I've got the more and right ruler because it's more accurate. It costs about 5 times as much as this ruler, I bet. And I believe that is the way it was. Yeah, it can't be the other way. That is the way it is. Just drop the square, so that's clearly going to be square now, isn't it? Let's get the head in the shot. Oh, man. So yeah, that is the square. So, for a start, don't need any precision here, I don't think. We'll have one line across the bottom. And that'll be my data line. He says. Alright, there's a driveway being installed, so a whacker plate is being used. That's the noise in the background. Anyway, back to this plate. That's the final pattern. I have gone ahead and I drilled 2 holes, 6mm, and I cut the hacksaw down, cut the hacksaw down, cut the hacksaw down, cut the hacksaw down, close to the line, and I filed it to final dimensions on the X and Y internal bits there. There we go, a few steps later, and she is in there. She's in. Shazam. We have a bracket which looks like the piece of cardboard that I cut out. Remarkably like the piece of cardboard that I cut out. Yeah, I left this a little bit long, and well, it's spot on. Absolutely spot on. Yep. Captain, we haven't got a problem. There we go. So apart from the 3mm extra rise here, which may interfere and may not, I might have to cut it off and weld it back on again, but ah dear. Right, let's get you set up into the position so you can see me fit in that. Not quite sure how square the framing is there, but I think you've got a very good shot of what I'm playing with. Here is the bracket coming in. There, so it needs to go there, like that. Oh, yes, indeed. That will, when I tighten that up, that will give me the strength to hold that there nicely, and it won't have enough torque to twist it down. That's the theory. So let's get on with it. So carrying on chatting. Right, I am not sure how much you can exactly see. I've raised the Z axis up to a point where I can stuff this piece of wood up behind, and I can feel it just here. I'm going to drill this first hole. I've got lots of packing in there. I've put a couple of pictures on and I've shown I'm using my little easier to control drill. It's a lot more lightweight. I don't know if this drill is sharp. If it isn't, I will swap it out and we'll try again. Well, I'm not sure exactly how sharp that drill is, but it's certainly making an indent into the steelware, as you can see. Oh, I'm sorry, I've just tapped the camera. I'm just trying to steady you a little bit. I'm wearing this cap, and I've done it again. Right, let me take the cap off, because although it's protecting me from damaging my head, it's making everybody watching seasick. Into the divot. And yes, I should be drilling with a way faster speed than that, but all I'm worried about now at the moment is getting a divot. Now I measured these with a ruler, so they're within 20 to 30 thou have been good. I'm not sure if the wood's behind that one, so I'm just going to angle the wood in a little bit to make sure it is behind that one when I go through, because I'm going to go through, I can assure you. That's in, that's through. That's through. And we've got wood again. Right, thankfully I haven't got iron filings everywhere. Just quickly before I put the other two holes in, I'm going to need to do this. So I'm just bringing the thing down to move 1mm. Just making sure that it's not going to rub. Unfortunately it's not turned out to be square. Yeah, it's clear all the way around, but I'd have liked it to have been a bit further up. That's where I've drilled it now. It's not perfectly straight. And that looks half decent, so it must be half decent. That looks brilliant. With that, yeah, that's going to be fine. I'm probably going to end up cable tying around it as well, just to give it more support like that anyway. So, I brought it in for the last little bits anyway. So just a little mark there, a little mark there, extra mark, even more of a mark. You get the gist. There we go. Hooray. There we go. They don't look too shabby. So I will scribe a line up there. A deep line. This is definitely going to drop. They're stainless bolts, so they're not magnetic. So there's the marks I got. And from that I'm going to interpolate where that hole needs to be, which is going to be around about right there. So I'm going to drill and tap that. I'll get tube inserted. So drill and tap it, make sure it fits. Shapey around here. Shapey around here. Yeah, it's a bit dingy and dark in there, but I think you're getting the gist of what's happened. Let's put the last bolt back in again. For a start, drilling and tapping in fresh air at M6 doesn't work great. So the union is not square. It's all collecting. This is the silicon bed heater. Oh, good grief. Alright, let's mark here again. This is the silicon bed heater. I know you're a bit wavy, but it's a Kinovo silicon bed heater. Once that's fitted, I'll be able to do full size prints. This is absolutely awesome with what light in there. There is the engine bell diameter, I think. So the brilliant goes to about 100mm, and that was over 100mm, but it did it clung on. little modification. Solid. It's solid. It's solid. For those of you that are not familiar with this, this was a car amplifier. Scrapped. I have inserted two power supplies, one 24 volt, one 12 volt power supply inside it. On top of it I have made a heatsink out of aluminium, bored some holes for fans, one blows into it, one sucks out of it, so I should get some flow through this aluminium heatsink, which is containing a solid state relay. It's a 40 amp solid state relay. It can take up to 380 volts AC and from 3 to 32 volts, sorry about that, from 3 to 32 volts DC. There's a polarity labelled on the DC, so I've had to figure that out, and I have done that. There is a mess of jumbled wires on top of it, and this isn't part of it. And then inside the 3D printer, which you can't see, is a Kinovo. So this is the company that send out these to you. It's a Kinovo 750 watt AC bed heater. The reason I've gone for a alternating current bed heater over a DC current bed heater is because the motherboard of the 3D printer does not have to supply the current. The main supplies all the current for the bed, freeing up all the current that the motherboard can handle for driving stepper motors and extruders and all sorts of things other than the bed. Anyway, the solid state relay DC side, which is this side here, it says 32 volt DC or 32 VDC. I've put a connector on it, just a quick release connector on it. That goes into the wiring extender which I made for the CTC 10S. So this is a standard connector what the CTC 10S has, which is the same as a Creality 10S. And also on that lead, apart from the bed heater, is the bed thermometer. And I've soldered onto that. I've cut off the other end of the extension, which is the female side of one of those connectors, so they slot into each other and then unslot from each other and come to pieces and get annoying because you haven't screwed them back together yet. And soldered on the JST female connector, and that can connect to the temperature sensor somewhere. It is here somewhere. There we go. So that can connect to that wire. So basically now I'm going to plug this into the 3D printer, and I will have the 12 volt coming out which went to the bed heater, and the two wires which were for the temperature sensor in the bed. That's them. This is a connector which is at the back of the unit of a Creality CR10, or in my case a CTC 10S. That would poke out the end, and this would plug straight into it. We'll demonstrate that. It does plug straight into it. Okay, so I'm going to go and plug this into the back of the 3D printer, and then this is from the bed on the 3D printer. It's now got the AC connector on it, so I'm going to plug the connector into what will be the new 3D printer computer, with this inside it. And now I've got a 9-pin connector. I'm using the top 3 pins, one for an earth, and then 2 for a live and neutral going to the bed, and then 1, 2 here in the back of the connector for the temperature sensor going to the bed. One of these wires goes through the solid state relay and is broken by the solid state relay, and both of those wires go into this connector here. This connector is just a parallel connector which connects each of the 3 wires up and then sends them back into this 9-pin connector, and then it comes out all the way through this black cable here out to a 3-pin socket which was on an old compressor which I've just salvaged. The other wires, which is another set of white wires here, this is a link wire which goes from one side of the 24 volt power supply and brings 240 volt AC power to the power side of the 12 volt DC power supply, and this wire here is what's going to connect single phase power to those power supplies underneath when I put the control box on this. And I'm not using the new control box with the new motherboard in and the new touchscreen and everything at present. I'm still building that, but I want to use a new bed, so I'm cobbling up, bypassing everything with this bit which will be inside the other computer. I'm just bypassing it with all this gubbins that you've seen here that I've just gone through. So I've swapped the amplifier around end for end to get the wires closer, and that has allowed me to plug that in there. So that's connected. Down that side, give myself a bit more wire inside. And there's just one more thing to connect, and that is the 3-pin plug that the SSR is plugged into. But for a start, I think we can see the screen here. I think I'm going to turn on the CTC 10S and see if it's actually reading the bed temperature. So let's switch on the CTC. I think you can see that booting up there. I'm pretty certain. Where's my hand here? You can see that booting up here. I'm not sure if you can see the reading on the screen. So yes, I've got 22 degrees centigrade on the screen. Now I'm going to jump around the back of the camera and I'm going to plug in the amplifier. I'm going to see if any sparks start flying. I'll turn the switch off for a start, which it's going into. Yeah, it's off. And then we will plug it in. It is in. And then we'll switch it on. No sparks yet. Good, good, good. There's no light on yet. So I will go into the control menu and down to the control, temperature, come on, temperature, and then we'll go bed and we'll stick it up to 100 degrees centigrade, no, 100 degrees centigrade, yes, 100 degrees centigrade, and back to the main menu, and let's see what's happening, because I can't, oh yeah, oh my word, 26, 27, I'm not sure if you can see any of that. Let's see if I can zoom in a bit. Yeah, but you're not sort of in there, are you? I can't do anything. Right there, no, there we go. Zoom a bit more. And try. Oh, this is just too much, this is. Everything's upside down and back to front. So it's at 50 degrees, it is rising. Is it getting hot, I wonder? Am I feeling heat? I might well be. Now bearing in mind that all this is live cabling in front of me now, I've got to obviously pay attention to what I'm touching because everything's live. And yes, the light is on the SSR now. we're about at temperature now, but what I've got is this bed, which is red hot now, 90 degrees centigrade, is higher. So I need to adjust the Z height end stop, and that's down here. It's not the easiest of things to do on these. I don't like touching it. I usually use gauge blocks to adjust it, but I know this time I'm not going to get away gauge blocks, so I'm going to have to punt it up a little bit. Back into where more or less it should be. Gauge with isopropyl alcohol. As long as that's not two feeder gauges together, that's 0.2 mil. And that is the layer height I'm going for. I have set it printing. It is printing these. Let me zoom in a bit so you can see where I'm printing. There's a bit of it printing, and here comes the bush in front of your face. I can get you. I'll zoom in. Yeah, I think you're seeing that now. So it's a little plastic bush, and that goes in the back of the RC car. So here is the RC car. Let's zoom out a little bit. Right, let's zoom in a little bit, then zoom out a little bit. So here's the RC car, and the suspension have little bushes which go in there, and the ones that are printing are the ones that go at the back here. So there's one there, and then inside the vehicle you can't see it, where my finger is, just inside there. There's another identical bush to it, although they're called different letters in the instruction booklet. So I went out shopping and I got this error come up. Change filament. I've only got blue, so I am going to change it for blue. So apparently it's working. I don't know. We'll soon find out. Sorry about the vibrations. But you tuned in to the. There is the printer, and there's the printer happening there. There you go, right in frame. Okay, cool. Let's just zoom out on that so you can see. I'll open up the tent. It's not the best thing for it. I don't see any glue coming out yet. I don't even know what's happening at the moment, to be fair. I don't know what's happening. And it looks like we're getting adhesion on this. So we're in the attic waiting for the batteries, which will go up in the attic with it, and this looks like it's getting adhesion, and that is mightily fine. So I'll let this complete, and it's very nearly complete now. We'll put the lid back down and keep some heat into it, although I've already done the dastardly deed of letting the heat out, but the plate should be really hot. It is, it's really hot. Hope that's transferred to the plastic being hot and the adhesion being good. Alright, it has been going, sorry, it's been finished quite a while now. Let me just pick up this battery that's just fallen off, which is obviously going to do it again and again and again until it decides not to. Anyway, the bed has been switched off now for a good 25 minutes. The old bed would be stone cold by now. This one is still 50 degrees centigrade, so it will not be easy to extract these parts. but I think I will manage it. Having said that, just go over the brim. And it might not be very good anyway because they're dual coloured and I've never done it before like that. 3 of them are staying on. There we go, I think that's all of them off. They're all off. So there's a couple that are attached to the brim still. As you can see, the holes print on them. They're printed really nice. Yeah, the blue's a little bit more swollen than the black. Well, not to worry. I'll leave them there for the time being. I'll leave them there for the time being. I'll clean them up in a bit. Because right now, I am going to reheat the bed. Do this. Heat it back off again, reheat it, and I'm going to print a wing, which is even more difficult, and there should be enough left on this blue to print a wing. And yeah, that's just stuck straight away, not even a problem. I would be worrying at a part that is that wide whether it was going to stick. Now after around about an hour it would start peeling, so I'll come back after an hour. I'll get you off the stand there, we'll take a look through the window and see if the edges are peeling up. Hopefully they are not. They might well be. So I'm going to dismantle this old bed now. I'm going to cut it down until it's 100 by 100, the size of the heating pad in the centre. And then I'm probably going to make a little 3D printer out of it, which takes the 100 by 100. But the idea of it was getting this bed working today and yesterday was I want this aluminium sheet to make a rear wing. Ironically, I've downloaded a wing off of the Thingiverse and I'm printing a rear wing which supposedly screws straight onto my car, but I'm still going to make a 2mm aluminium wing out of this, or whatever it is, 2mm, 3mm, 2mm I think, out of this, bend it into the position, into the shape that I want, shape it up on the milling machine, drop the holes in, and I'll probably end up using this because the plastic 3D printed wing will more than likely be destroyed the first time the car rolls over. It has finished. The bed is reduced in temperature to 65 degrees centigrade, and I should have a wing as it cooled. Oh, I promised to bring you in closer, didn't I? Let me bring you in closer so we can have a good look at it. Let me just get me. That's pretty good. So, very often with the old bed, all this area here would have been lifted. This is like a pointer, some sort of pointing device that I have. So all this area here would have lifted, and as that lifted, at the time it lifted, whatever level it was on up here, that would have been compressed, and there would have been some curvature down here, and it wouldn't have been very good. And on the side, get as far as I can. Yeah, there's no lifting there as far as I can see on the camera. Oh, there's no lifting at all. Not any. Oh, it's out of focus. So the new bed's doing its job. So I've got the Canovo silicon bed heater. It's alternating current, not direct current. We've got a 5mm piece of, forgive me, I don't remember what it was. It's either aircraft grade T6 7000 series or it's 6000 series. I can't remember. I just don't remember what it is. Aluminium, 5mm thick, brilliant thermal mass on it. It holds the heat amazing without any insulation. And then I've got the Creality silicon board glass with the nano coating on. So the aluminium was just a offcut off of eBay for around about 15 quid, 10 quid. I milled it to size within microns just because I've got a milling machine. The bed I bought the silicon heater I bought. I can't remember how much it was. It's worth its weight in gold, clearly. No wasted material here. So it's already saved me a little bit of money. I've got a part, awesome. And then the bed top, I think that was about 12 quid for the piece of glass, which was really reasonable, in considering to the stainless steel one I've got and the other ones I've got. So I think that is it. Bed is done. This printer is way better now, way better. She's going again. She's making a battery holder for me FSGT5 transmitter for my RC car. I've been designing this here, this chassis here, for a couple of months. I wanted a test print. It isn't very good, it's 5% infill, so it's failed miserably. The most important thing is though, the base is completely and utterly the same flatness as the bed. That one's rubbish. So I went on from that and I have done another print. This is in PLA, it's a bit different. And again, that's 2 prints in a row, no failures. Perfect. Absolutely perfect. So that would have been a failed print anyway because of the size of it. As you can see, it is 200mm plus long. That old bed would not have done that. This new bed, it's doing it. So the upgrade continues for the 3D printer. The next will probably be the print head going to full metal hot end, because I need to, and hardened nozzles, because I need to print some carbon fibre, and I want to do it in ABS. When I say near enough complete, I've just fetched it and cut the video here. Here it is. These aluminium fan holders are not what you saw on the CAD drawing, and they will not be the final item. They're just quick. So I've got to make the BL Touch mounting system that this mounts to, and then this is ready to go on with the BL Touch system, so then I can use automatic bed leveling, which will increase the reliability of the first layer and make using the printer so much easier, I hope. Anyway, the temperatures I'm printing at, well, I'm going to be printing at, and the plastics I'm going to be using, I can't allow the BL Touch to experience those temperatures, so its mount has got to be fabricated, blah blah blah. There you go. She's working beautifully. New bed, get one on. CTC 10S, now tremendously better for not a lot more money. Piece of aluminium, silicon heater bed, Creality bed, stick straight away, no problem. PLA, bang, 80 degrees centigrade. Pet G, the blue one that you saw earlier, 90 degrees, bang, stick straight on, perfect, awesome. There we go.